Hello everyone, my name is Vipin Amram and in today's video we are going to talk about balancing of force and electric field. So let's get started. Let me try to make you guys understand what I mean by balancing of force and electric field. So in our previous videos we have talked about force, we have talked about electric field, but in today's video we are going to talk about where I can balance these forces and electric field. Didn't get me? Okay, let me make you guys understand with an example. So as you guys can see that I have a charge q over here and I have a 4q charge over here, right? Two charges and they are separated by a distance of a, right? Okay, obviously we know by Coulomb's law they are going to experience a force of repulsion because both the charges are positive, right? Yes or no, they are going to experience a force of repulsion, which you can very nicely give F is equals to kq 4q divided by a square. Yes or no? I hope that is understandable. Yes, great. Now let's say I brought a positive q charge in its vicinity, right? I brought this positive q charge in the vicinity. The moment I brought it, this q charge is going to experience a force of repulsion because of 4q charge in that direction and because of q charge in that direction. Yes or no? This positive q charge, the third charge which I brought, is going to experience a force of repulsion because of these two positive charge. Yes or no? Right? So in today's video we are going to find a place where this q charge is not going to experience any force. Now what does that mean? Is that even possible? Yes, it is possible. The simple solution is that I am going to place this q charge somewhere in that position where the repulsion from 4q charge as well as q charge are equal and opposite, and hence when they are equal and opposite they are going to nullify the effect of each other, and hence the q charge is not going to experience any force. I hope that is understandable. The same story goes with your electric field. I will explain the electric field part in the later of the video, so do keep watch the full video, right? Okay, now in order to find that position we have to go through these nodes. These nodes will help us where I should place my positive q charge so that I can get that point where both the charges, both the effect of the charges are nullified, right? Okay, let me read that out. Note number 1 says that if both side charges have similar nature, that means talking about side charges, one was 4q, another one was q, right? So if both side charges have similar nature means if both the side charges are positive or both the side charges are negative and are fixed. This is very important, they must be fixed. Obviously we are still on electrostatics chapter, so definitely charges are fixed, they are not moving anywhere. Yes, so are fixed. Then the third charge can be found in equilibrium. Okay, the third charge which I brought, it can be found in equilibrium in between on the line joining the two charges. So according to the note is saying that if your side charges are of same nature, that means they are positive or they are negative, right? And you're bringing your q charge, that is your third charge, right? So when you bring your third charge you can find that equilibrium position means where both the effect of charges are nullified on the capital Q charge, right? So you can find an equilibrium position in between the line joining the two charges. That means let's say if this was my first charge, this was my second charge, right? q 4q, right? So I can put my third charge in between these two charges and on the line joining both the charges. That's where I can find my equilibrium position. Somewhere here, I'm not sure about the position, but it will be in between and in the line joining, on the line joining both the charges. I hope that is according to our note first, right? Great. Let's go to note second. Note second says if two side charges have opposite nature. Now opposite nature means one is positive, another one is negative, and are fixed, obviously fixed, right? The third charge will be in equilibrium outside the line joining the two charges and towards the charge with smaller magnitude. That means, okay, so this means that, okay, if I have two charges again, right, if one is positive, another one is negative, then according to our note, I'm going to find the equilibrium position, but this time this will not be in between, right? This is outside the line joining the two charges. This time outside the line joining two charges and towards the charge with smaller magnitude. Okay, so let's say if this was 4q and this was q, so you guys can see this is the smaller magnitude, q is the smaller magnitude, yes or no, right? So I can find my equilibrium position somewhere outside the line joining the two charges, but this will be closer to the charge which is having smaller magnitude out of both, right? So this has 4q, this has q, that means it will be closer. Now for example, if the position, if let's take for the time being, let's say if this was 4q and this was minus q, then definitely the equilibrium position will be somewhere here and not here. I hope you guys understood what the note is trying to say to us, right? If that is understandable, let's go and try to do some question based upon that, so that we can get a better understanding of what we have just heard, right? Okay, great. So here you guys can see we're talking about the same thing. I have position A, position B, q and 4q charges are there, they're separated by a distance, and we have to and I'm going to bring a q charge. I'm going to bring a q charge and I'm going to place it, because you guys can see according to our note 1, if both the natures are same, if they are fixed, right, then I can bring my third charge and it can be an equilibrium in between the two charges and on the line joining. So I'm going to bring this charge and I'm going to place it over here. Let me call it charge q, let me call it point C, right? And I have no idea where is this position, right? So let me say this is at some x distance from my A, right? And obviously the rest will be a minus x. Great, I hope that's understandable, right? Okay, so according to our question, the question that this is my assumption that this is that place where the effect of both the charges are equal and opposite, right? That means this C point is going to experience a force of repulsion because of A point, right? I can write it force on capital Q charge because of small q, yes or no? Very similarly, I'll get an opposite repulsion, force on capital Q charge because of 4q charge, yes or no? And they are going to be equal and opposite according to our assumption, yes or no, right? Great. So if that is true, let me just put that in mathematical form, right? This is f q 4q, the magnitude of this is equal to f q and small q, yes or no? They are equal in magnitude, right? Now all I have to do is apply Coulomb's law and let's try to do it, right? Okay, great. So when I say fq 4q, that means I'm talking about this q charge and 4q charge, right? And they're separated by a distance of a minus x. Keep that in mind, right? So if that is true, let's try to do this. So when I talk about fq 4q, just apply Coulomb's law. K, yes, this will be q, and 4q divided by distance between them is a minus x whole square, right? And that will be simply equal to, yes, k, q, and this time q and small q, right? Distance between them is x, yes or no, right? So all we are going to do is apply Coulomb's law. K, q, small q divided by x square, yes or no, right? K will cancel out with the k, capital Q will cancel out with capital Q, small q will cancel out with small q, and we'll be left with, yes, 4 upon a minus x whole square, and that is equal to 1 upon x square, yes or no, right? So simple, taking square root on both sides, square root on both sides. So I'm going to take square root on both sides. So the moment I take square root on both sides, I'm going to get two roots here, right? This will be plus minus 2 upon a minus x is equals to 1 upon x, right? I'm going to talk about only the positive root. Negative root does not affect me, so I'm going to talk about positive roots, right? So I'm omitting the negative root, so I'll get 2 upon a minus x is equals to 1 upon x. Do the cross multiplication and we will get 2x is equals to a minus x, right? I'm supposed to find out the value of x, so this 2x plus x is equals to a, or I should say x is equals to a by 3. Now what does that mean? I got x is equals to a by 3, right? That means, very simple, that means I got the value of x to be a by 3. That means the charge q have to place it at a by 3 distance from your a. From your position A, you have to place it a by 3 distance in that direction, right? In this direction, right? So if this is a by 3, then a minus a by 3 will be simply, this is 3 a minus a upon 3, right? So this will be 2a by 3, right? This is 2a by 3 from 4q charge, right? 4q charge, from 4q charge is in that direction, right? I hope that is understandable, right? So I got the position, right? Okay, let's, if that is understandable, let's go to the next question, right? Next question says the same thing, but this time my natures are different. This time I have a q and I have minus 4 cube, right? So this comes to our second note. I hope you guys are following. This comes to our second note, right? According to our second note, if we have opposite nature, if they are fixed, then you can bring your third charge. You have to place your third charge outside the line joining the two charges, and it will be closer with the smaller magnitude of the two, right? Out of the two, right? That means you guys can see q is the smaller magnitude one, right? So definitely the third charge which I'm going to bring, right? Third charge which I'm going to bring, I have to place it somewhere here. I have to place my third charge somewhere here, right? Which I have no idea. Let me call it, it is some x distance away from your a position, right? Let me call it position C. Yes or no? Great. Now let's apply Coulomb's law, right? So obviously this q charge is going to experience a force of repulsion because of your small q charge. Let me call it force on q because of small q, and it's going to it's going to feel attraction because of minus 4q charge. Let me call it force on q because of minus 4q, right? But according to our note, according to our assumption, these forces are equal and opposite, right? So let's do it, let's equate it. So that means your FQQ in magnitude is equal to FQ minus 4Q in magnitude. Yes or no, right? I hope that's understandable, right? Great. All you have to do is apply Coulomb's law, right? Apply Coulomb's law. FQ and small q, that means we're talking about FQ and small q, right? They are separated by distance of x. Remember that, right? I hope that's understandable, right? Okay, let's write that. KQ upon x square is equals to, let's talk about next one, FQ minus 4q. You guys can see FQ and minus 4q, they are separated by distance of a plus x. I hope that is understandable. A plus x, right? Great. So let me write that down. K capital Q, and this is 4q divided by a plus x whole square. I hope that is understandable. Yes or no, right? Great. All you have to do is cancel out the k's, cancel out the q's, right? And we'll be left with 1 upon x square is equals to 4 upon a plus x whole square. Great. Taking square root on both sides. So when I take the square roots on both sides, this will get, you will get two solutions, plus minus 2 upon a plus x. I'm going to talk about only the positive one. I'm going to omit the negative roots, right? So that means this will be 1 upon x is equals to 2 upon a plus x, right? Do the cross multiplication. So when I do the cross multiplication, a plus x is equals to 2x, right? Or a is equals to 2x minus x, or I should say x is equals to a. Now what does that mean? It means that your x, the value of x is actually a. Your c position is a distance away from your a position, and it is 2a distance away from b position, right? I hope that is understandable. Yes or no, right? Great. So I hope you guys understood both the notes. What does both the notes meant, right? So if that is understandable, let's extend our exercise to electric field, right? The only difference between force and electric field is that whenever we talk about electric field, we always talk about test charge, right? So for example, if I have a charge q and I have to find out electric field because of this charge q at some point p, how I do it? It's very simple. I bring a test charge, a positive test charge, that is q naught, and I place it over there, right? And this positive test charge is going to experience a force because of the electric field produced by the capital Q charge. Yes or no, right? I hope that is understandable, right? And the test charge, the force experienced by test charge per unit test charge is what, this is how you find out your electric field. I hope that is understandable, right? Clear? Great. So now about electric field, as you can see over here, I have a charge, I have a q charge, I have 4q charge, right? So in the previous one, that means we talked about force, right? So in the force, whenever I brought a q charge, there was a force of repulsion. But in this scenario, we are going to bring a test charge, right? So let's say I brought a test charge, right? Now this test charge is going to experience force because of the electric field of both the charges. Yes or no? It is going to experience a force because of the electric field of both the charges, right? Now our question is, or our part is to place this q naught test charge in that place where it is not supposed to experience any electric field or force because of these two charges, right? It's pretty similar scenario as that of the force, right? The only difference is this time I'm going to bring a test charge, and this time we're talking about electric field. That is the only difference here, right? And the notes which we have studied, the first note and the second notes, are still going to be useful, because you guys can see this is positive charge, this is again positive charge, right? So when we have two side charges with they are having the same nature, then your third charge, the charge which you are bringing, can be found in equilibrium in between these two charges, and on the line joining these two charges. So that concept still remains same, right? Okay, great. So according to our assumption, I'm going to bring this charge over here. Let's say, let me call this place C, right? And let me say this is some point x away from A. Obviously then this will be some A minus x away from B, right? I hope that is understandable, right? And very clearly I can see that when the moment I brought this q naught charge, right, this is going to experience the electric field of q, right, in that direction. Let me call it electric field of q, and it's going to experience electric field of 4q in, it will be in that direction. Let me call it E of 4q. Now according to our assumption, these two electric fields are equal and opposite, right? So mathematically I can write it, electric field of 4q is equal to electric field due to q, right? I hope that is understandable, right? If that is understandable, all you have to do is put the values over here, right? Electric field because of 4q at that point will be simply equal to k. See, we are talking about 4q over here, right? So that will be k 4q divided by distance between them is a minus x, right? So it is a minus x whole square. I hope that's understandable. Very similarly, electric field because of q q, we're talking about the electric field over here, right? Distance between them is x, right? So very simply k q upon x square. I hope that's understandable, right? Cancel out the k's, cancel out the q's, you'll be left with 4 upon a minus x whole square, and that will be equal to 1 upon x square, right? Next step, take square root on both sides, right? Take square root on both sides. So the moment you take the square root on both sides, you will get two roots, right? That is plus minus 2 upon a minus x is equals to 1 upon x, right? And again we are going to take only the positive root, neglect the negative root, right? So you will be left with 2 upon a minus x, and this will be equal to 1 upon x. Do the cross multiplication, you will get 2x is equals to a minus x, or we can simply say over here that this will be equal to, as you guys can see, 2x plus x is equals to a, or I should say 3x is equals to a, or I can say x is equals to a by 3. Right, now this is very important. Now why I'm saying important, because the value of x is a by 3. That means you have to place your q naught test charge at a by 3 distance away from a, right? A by 3 distance away from a, so that this q naught charge, the q naught charge does not experience an electric field because of q or because of 4q. I hope that's understandable. Now I have one more example, right? Now this example, it's very simple. The only difference with this example is this time I have opposite nature of charges. This time I have opposite nature of charges, right? One is minus 4q, another one is q, right? So according to our note, I'm going to find my equilibrium position for electric field somewhere here, right? It will be closer to my small magnitude charge, right? So q naught will be over here. I will place my test charge q naught over here. The moment I place it, what is going to happen? This q naught is going to experience a force, or I'll call it electric field because of q, and this is going to experience electric field because of minus 4q. Both the electric fields are going to be equal but in opposite direction, right? So that is according to our assumption. All we have to do is put the values. Electric field because of q will be equal to electric field because of minus 4q, right? I hope that is understandable, right? And all you have to do is put the values. Electric field because of q will be, as you can see, this electric field because of q is actually some distance x away from it, right? And because of 4q, it is actually a plus x distance away, right? So when I talk about q, you can write k q upon x square, and when I talk about 4q, you will write k 4q upon a plus x whole square, right? Cancel out the k's, cancel out the q's, you will be left with 1 upon x square is equals to 4 upon a plus x whole square, right? Take the square root on both sides, take square roots on both sides. So when you take the square root on both sides, you will get two roots. This will be 1 upon, okay, this will be 1 upon x is equals to plus minus 2 upon a plus x, right? Again we will be focusing on the positive roots. We are not talking about negative roots, right? So you will get 1 upon x is equals to 2 upon a plus x, or you can say a plus x is equals to 2x, right? Or you guys can simply say a is equals to 2x minus x, or simply x is equals to a. Now what does that mean? It means that this distance is a, this distance is a. That means your point C, the place where you place your q naught charge is actually a distance away from point A. I hope that is understandable. So that was all about balancing of force and electric field. I hope you understood the lecture. I hope you understood the video. If you did understood, do like and share and subscribe. I hope all of you are doing good. Stay home, stay safe.